everyone. My name is Priyati, and today I am pleased to speak with Sanjeev Sharma, founder and CEO at Swaayatt Robots. It's a company we founded in 2015, and it's developing autonomous driving technology for highly unstructured traffic conditions. And in this interaction, we aim to learn about the concept and nuances of autonomous driving and also Swaayatt's approach to problem solving. Hi, Sanjeev. Welcome to Evil Portal Podcast.
Hi, Priakshi. Thanks for having me here.
Thank you so much for taking the time. So before we start, I would like to learn a little bit more about your background and
Sure,
what triggered you to spend so many years, maybe starting right from an undergrad on this.
sure. Sure. So I started my journey into autonomous navigation research when I was in my fourth semester undergrad. So I did my BTech in electrical engineering from IIT Roorkee in 2011. From 2011 to 12, I was in Israel where I was developing motion planning and decision making algorithms to enable robots and autonomous vehicles to navigate high-speed synchrotron environment. From 2012 to 14, I was at the University of Alberta doing MS in computing science. In 2014, I got admitted to PhD at the University of Massachusetts Amherst computer science PhD program. But instead of going for PhD, I came back to India. So my journey into autonomous navigation research started when I entered fourth semester of my undergrad. So I was inspired by the DARPA Urban and Grand Challenges videos, especially by one of the videos by Team MIT. And that's when I decided that solving autonomous driving in the most complex of traffic dynamics and in the environments that could be considered as these most adversarial of environments for autonomous driving. So since then, I started my mathematical journey into the field of autonomous navigation, uh, primarily focusing in certain areas of artificial intelligence that allow autonomous robots or vehicles or agents in general to be able to make optimal decisions. So my journey started with machine learning, AI, and currently at Swaayatt, since founding Swaayatt, I've been researching on like around 15 plus different areas of theoretical computer science and applied mathematics. So yeah, this is how I got started. This is my background in general. After coming back to India in Swayat, after I got admitted to PhD program, I took 1 year deferral and came back to India. So I had 1 year. So since I've been doing my research and building my background like mathematically since undergrad, I had enough time to to experiment. And when I was in India for a year, I sort of developed certain algorithmic frameworks. The backbone, the foundation of which had been laid during my undergrad research itself. So I sort of further developed those algorithms and realized, okay, that maybe like I actually could solve the problem. So in 2015, I gave the PhD offer and started working at Swayat full time. From 2015 to 2021, Swayat was bootstrapped. In 2021, we received our first round funding, $3 million at $75 million valuation from investors in the US. And even before funding, you could see the research that I was doing and the work we have been doing at Swaayatt Robots. It allowed us to demonstrate autonomous vehicle navigator in Indian streets, like way back in like 2016 and 17, when only Google and Uber were the two companies globally. And after funding, as you can see, like we have done in total, like over the past few years, we've done like 75 plus demos overall on Indian roads and Indian environments.
Yes, yes. No, I've seen some of your demo videos and it really piqued my interest. But before we move on to the technology part, one more question on
Sure,
why autonomous driving? I mean, at the end of it, what
sure.
are the benefits that we are seeking by enabling this technology?
Sure. So I think you asked about my background. So I think it's somewhere you would have realized like I love to solve only the complex of problems. So autonomous driving happens to be the most challenging. I mean, now even more so. I mean, after having been in this field for 10 plus years, I realize it's even much more difficult. But back then, I mean, sort of like autonomous driving is like I have a technical interest in this area. Like I really want to solve this problem. It is the most complex of AI problems of this decade, and perhaps the next to come as well. And if you're asking in the present scenario, like in this decade, I mean, as you know, like there are certain areas of AI. For example, if you work in NLP or any other domain of AI, for example, right? I mean, there are only parts of the problem, parts of the like some of the areas that you're working on. Autonomous driving happens to be an area where there's no limit to the mathematical depth that you can go to.
Hmm.
There's no predefined boundaries that you should work in certain number of areas to solve this problem. And if you were to solve the level 5 autonomous driving problem everywhere, I mean, then practically what it means is that you have developed a level of sophistication in the AI system that it can go in and solve many other different problems as well. The similar things you have seen, some of the parallels you can see in the area of like ChatGPT, OpenAI doing like general AI research. It has so many applications. Same goes for DeepMind as well. But still, like they were limited by the problem that we're solving. What autonomous driving allows you, because you are actually working with a real world robotic system, and you have to make decisions like humans do, which is, and that too in a very like continuous, like very complex stochastic traffic kind of scenario. So if you solve this problem, then you're going to solve many other problems as well. Furthermore, autonomous driving happens to be a $10 trillion market by 2030, right? Addressable market. So it's a very huge, like huge business opportunity as well. So if the questions come from business and business standpoint, then yes, I mean by 2030 we would like to be as one of the few, like 4 to 5 companies will survive by then. We would want to be one of those 4 to 5 companies by 2030 who provide like sort of autonomous driving services.
Right. And if we talk more in a still broader sense, like
Yeah,
apart from AI, with if you compare with regular human driving,
sure.
do you think autonomous will solve for some of the issues related to safety and on the roads? Do you
Yeah,
think
definitively. That
that be
is
an outcome, or is that because that is an inherent risk basically that companies like you are trying to solve using
true.
your algorithms? So at the
True.
end of it, when we achieve that level 5 autonomy, proven and validated in different markets, so are
Sure.
we saying the roads will be safer than what they are today?
For sure, that's a natural byproduct of the technology at large. I mean, that's what the objective of level 5 is. I mean, if you can develop technology that can, sort of allow autonomous vehicles to make decisions like humans do, then machines don't make errors unless their sensors are at fault. They won't make error, right? And apart from that, if you talk about, this is regular like civilian application. I mean, you see like most of accidents happen in India like due to driver's error. I mean, most of trucks accident happen due to like drunk driving as well. Similarly, apart from this, I mean, and this is just India. Take this like globally, and you can actually make roads much more safer. Furthermore, there's another sort of application of transit which is in the defense sector. So this is definitively going to save lives, precious lives, and be able to do some of the tasks that are like very very complex and very dangerous for humans. Furthermore, there is also like search and rescue robotics, which is one of the most prominent applications of autonomous driving. So by just developing this tech, I mean, and if you talk about autonomous in general, I mean, if you look at drones, for example, which is another application of this technology at large, and these systems, these robotic systems, these agents are going to be useful for multiple scenarios, like civilian. Definitely autonomous transportation is going to be much more safer. You have defense application, then you have search and rescue robotic applications as well. So yes, I mean, definitely I think like it will make lives much more safer on road.
Understood. Okay. So I've seen a couple of your demos, and in different demos, you've shown capabilities of negotiating high traffic, bi-directional traffic negotiation, going to a toll plaza, night driving, and so on. So help
Sure.
us understand what is the current readiness level of your technology?
So currently, if we talk about readiness, except for autonomous driving in the core city traffic during daytime, I think uh, we can handle almost every scenario. And this is what we have been showing through our demos in parts. Now, why we are not able to do a holistic demo like A to B, because that requires significantly much more resource and much more funding. So what we're doing, when you're seeing our individual demos, for example, when you see our toll plaza demo, when you see Bhopal city navigation, when you see off-road, now these are actually different verticals as well. That if you look at the global autonomous industry, except for like companies like Waymo, which is like solving entire problem from A to Z. Even if you look at the Tesla, they have like autopilot to offer. If you look at Mobileye, whose system comes, in India in the form of XU700, it's only like sort of a very simplistic level 2, level 1 ADAS system that is able to take steering control on the road. So these are small like off-road autonomous. It's a totally different segment altogether. If you look at the global trend, there are only three, I think there's no more than three companies who is trying to solve off-road autonomous driving, and anyone who is off-road, they are not an on-road, because these two are very different problems, and very and having their own complexities. But what we are showing, how we are taking the problem of transferring is we are taking it as one holistic problem, right? I mean that we have to solve the problem generalized autonomous navigation, and there are different verticals of it. So when we did, like for example, let's talk about the bi-directional negotiation, right? So when we say that we are going to induce the level of intelligence that the technology will be at level 5, what does that mean? So the autonomous vehicle should be able to deal with unforeseeable scenarios, unforeseeable situations on the road. That is what the objective of level 5 autonomous driving is. And if you look at if you look at the global trend, they talk about corner cases where someone suddenly jumps on the road. So now if you can deal with bi-directional negotiation on a single lane road, what it means is that when you drive on the road, on that road, there's practically no driving law. I mean, people can come and go in any fashion. So there's a lot of unpredictability and unforeseeability as well. So when you and the kind of demo that we did was a single lane road, and there was side off road. Now, even a human driver, if you're not an expert driver who's regularly driving such road, you'll find it very difficult. Just give it to a novice driver who has just obtained the driving license. They would feel very difficult for them to drive themselves on that road. So when someone suddenly comes from the other end, your vehicle will have to shift off road. Now, how much to shift, when to shift, at what speed to shift, these are some very complex decisions. And fortunately, we are the first company in the entire world who is showing bi-directional negotiations on a single lane road, where you have no you can assume certain driving pattern, but any assumption is going to be invalid when you actually go on road, because there are bikers, there are trucks, and different four wheels. If you look at the toll plaza demo, now toll plaza was a very complex sort of arena. You have a vehicle coming from regular highway, so you have highway navigation over there. Then you have an open area where the trucks were, if you had seen the demo, the trucks were parked like zigzag in a very random fashion. So there is no law. You cannot you cannot pre-compute paths. You cannot use high fidelity maps, the typical approach taken by the industry at large. And even if you have incoming obstacles, they will not follow any driving pattern, because there's no lane marker. No, it's a general open arena. And once you are done with that, then there's a speed breaker before the toll gate, and then committing to the toll gate itself. So these are the kind of decisions, where vehicle has to switch from its decision making policy from one segment of the arena to the next, and one policy wouldn't work for the other segment. So what we are showing is a very complex decision making sort of scenario, where our vehicle was able to make sequentially optimal decisions to be able to cross the toll gate just like human drivers do. And when the vehicle entered the toll gate, there was a truck in front of it, and two trucks before it just crossed in a zigzag fashion. So the vehicle had to also, even in that situation, the vehicle had to decide what gate to commit to. These are the kind of decisions only humans can make in such a smooth manner. And this is where we showed, okay, we just don't have the capability to navigate highways. We have the capability to negotiate the traffic in generalized open area without any traffic law, and have the decision, the intelligence in the vehicle to be able to know when to cross a toll gate and how to cross it.
Hmm.
Similarly, if you look at the off-road demo, I mean, I think you might be aware of DARPA Racer program, which is a competition being held in the US right now, where the objective is to drive autonomous vehicle at human-driven speed. Now, our off-road autonomous driving research is solving two different problems at the same time. One is we want to achieve high-speed autonomous driving. So that is where, if you look at our April 2023 demo, not even the recent demo, April 2023 demo, if you see, the vehicle was navigating 44 kilometers per hour on a road where humans could drive only at 48 kilometers per hour. So very close to human driven speed. Now, the different part of the problem that we are solving. So autonomous, over the past 15 years, $200 billion have been invested into the industry to perfect the perception and localization algorithms. Where the autonomous vehicles have their visual sensors to know what is around them, and they use high definition, high fidelity map to fetch some of the information about the environment, which is already stored in the map. So we are showing an autonomous driving model that does not require high definition, high fidelity map. This we had solved way back in 2017 as well. Now we are moving forward. Let's suppose if you're driving a vehicle on road, for example, if you're having an ADAS system, then ADAS system will have to detect where the obstacle is, what their speed is. It will also have to detect where the lane mark and the road boundaries are. Now we are asking very fundamental question at Swaayatt. Can we get rid of these algorithms and have the embodied intelligence in the vehicle where it can process the visual sensory data and have it feel just like humans do, that this is something I cannot cross. So this is what we are demonstrating through our off-road answering research. So the second part of the problem is we are solving is, can the vehicle make end-to-end decisions without having explicit algorithms to perceive its environment. The intelligence would be embedded in the decision making layer. So we are
Hmm.
building this kind of a representation that allows us to kill these algorithms for off-road answering. And when this is done, this research will be brought to on-road autonomous driving, where you have significantly less redundancy into the system. You know that something can go wrong. So these are some of the major problems that we're solving, and we're demonstrating in part now. Why in part? Because as I mentioned, we just have $3 million in funding. So with the limited resources, we are able to build these intelligence systems and do their demo as a standalone demo.
Right. And also another part of doing these demos is definitely, does it require any regulatory approval? Is there a framework under which you are doing these demos? Or uh, I mean, I want to understand more because of one, what is the
Sure,
regulatory work for
sure,
autonomous driving? Is it still developing, especially with
sure.
respect to India? And
So
also
the
with
yeah.
respect to testing as well, what is the approach that you take?
Sure. So first, regarding the regulation, so the Motor Vehicle Act was last amended in 1988. There has been no amendment since then, and there is no mentioning of ADAS and autonomous driving as well in the Motor Vehicle Act. Now, if you look at the major companies, they are embedding their ADAS system into the vehicle and directly launching it as a ready to go like product in the market, like XUV 700 and the Ester MG Ester as well, right? These are two examples. When you do testing, right? So let's suppose if your vehicle hits someone or crashes, so this would be treated similarly as if you were driving the vehicle. Just like if your vehicle hits someone, then you as an owner of the vehicle or you as a driver in the vehicle would be charged with whatever. Right, so this is the same goes over here. What additional you can do is like I cannot go into much of the detail because since, as you mentioned, there's no regulatory framework being has been made so far, but you can always inform the local authorities. For example, let's suppose if you are doing a demo where you need to, maybe for example, like if, let's suppose we do a demo and we need some traffic to be blockaded, then you will have to inform your local police station and keep the local authorities informed that you're going to do a demo over here. Other than that, I mean, you have to be on the one safety driver has to be in the driving seat for it to be a legal sort of driving, and the Motor Vehicle Act does not sort of make it. That there has been a statement. I'm sure like you might be referring to a statement by one of the most famous politicians in India. But again, I think like that's a. I mean, it's not a law as of now. I mean, there's no law that prohibits autonomous driving, and there's as such no law that actually sort of any has any specific mention of the in the Motor Vehicle Act, like for transferring or ADAS for that matter.
Okay. Okay, now coming back to technology, I heard in one of your presentations you made that your goal is also to minimize the cost of
Yes,
technology so that it can be adopted on a wide basis. So you
sure,
said that you are using or you are developing algorithms to enable the use of off-the-shelf cameras without using radars and lidars and these sensors. So can you explain how is your approach different from what other companies who are also solving autonomous driving are doing?
sure. So this heavily, so the objective like can be defined by anyone, that our objective is to like solve the autonomous driving without requiring lidars or radars. If you look at the off-road autonomous driving demos, they make use of lidars, right? Because off-road autonomous driving has very different application. It has like defense application, and for off-road autonomous driving to make sense, I mean, you have to have a lidar in the vehicle. But having said that, we are going to do a demo in the month of August, off-road transferring demo without the use of lidar, just using off-the-shelf cameras. But if you look at the history of the demos that we have done, so um, um, we made through our algorithmic frameworks, we made lidar redundant way back in 2017. If you go back go to our demo November 15, 2017, when we were unfunded, so I was about bootstrap, we had developed a multi-reinforcing agent-based decision-making framework that allow autonomous vehicle to navigate using only two forward-facing camera mounted on front bumper. And our vehicle navigated in a colony kind of environment. Like, it was a very chaotic and very stochastic kind of an environment. Due to limited funding back then, we did a very limited demo just in the colony. If you look at the algorithmic frameworks that we have made over the past few years, like, we have the ability to perceive the environment both during the day and at night, using only off-the-shelf cameras without requiring radar. And one of the most prominent, I wouldn't give any number of algorithms as an example. One of the prominent example, if you want to look at, just look at our lane detection generation demos. There are like around more than 10 demos for this one algorithm alone. So way back in 2016, when I was working, to building the foundation of Swaayatt, at that point in time there was a challenge. I mean, back then, if you had to purchase lidar, you would have to spend around $100,000 to import in India. So there was no, and in total, I had only 60, 70, 80 lakh rupees of money to actually build the entire startup over the years. So the first research that we undertook was, this is what I coined de-interest generation, meaning, can we induce the intelligence in the algorithmic frameworks that they can not only pick the information that is present in the visual sensory data, but can they develop the contextual holistic understanding of environment and generate information that is not available in the visual sensory data. And one of the instances of this is a lane detection generation algorithm, which even if the lane markers are not present on the road, the system will generate them automatically on the fly, so the vehicle can perceive the environment being, as if the environment is structured, even though the inherent environment is unstructured. Similarly, we have made many different algorithms, but to make lidar completely redundant, and maps as well, not just the lidars but also the maps, because maps affect operational cost. Lidars and these sensors will only affect the purchasing cost, but at this point in time, when the technology is not matured enough, when it's only running the pilot form globally, people can afford the cost, the purchasing cost, but the operational cost is what affects the autonomous driving, application at scale. So not just the cameras but also maps redundant. So these are some of the algorithms. Furthermore, we have been heavily researching the decision making and motion planning. So we have developed some algorithms that are able to deal with very high levels of stochasticity, or you can say chaos, in the representation of the environment, not just in the traffic dynamics. So when you fuse the two, you have algorithmic frameworks that allow autonomous vehicles to perceive without requiring radar. And this is what we have been doing through our end-to-end deep reinforcing research as well. I mean, the present some of the demos, depending on what kind of demo we are doing, we select sensors. But if you look at our holistic demos, they're always done without the use of lidars. Right, like the one in 2017, like the recent demos, some of the demos we did, they were completely without the lidar. And the present research that we are doing using, there's certain area, like, so AI has several different branches. Like machine learning happens to be one of the most popular branches, and there's a branch on neural network, and then you have deep learning emanating from that. And then there's a further branch of machine learning which allows you to model the problem of sequential optimal decision making as a mathematical problem. So this paradigm is known as reinforcement learning. This further field, what is known as inverse reinforcement learning. So currently our company is heavily invested into some of these areas to completely make lidars and radars redundant for autonomous driving. And you would see more prominent demos coming in the month of March and April, where the vehicle will be navigating without the lidar.
Okay. All right. But the demos you've done so far, they use radars and lidars along with the.
Just a little. So, for example, there are certain applications of autonomous driving which are very contingent upon global accurate positioning of the vehicle. So,
Hmm.
what happens is that autonomous vehicles make, just like we make use of GPS maps, Google Maps. Autonomous vehicles make high definition maps. So, what if you're working last mile autonomy operation, for example, like maybe in the shipping terminal, or maybe in autonomous transportation, where your truck or your logistical like vehicle has to come at very specific configuration in a very specific part of the environment. So there the vehicle will have to know its position orientation with maybe centimeter level of accuracy. So those are certain application which require very accurate positioning with respect to high definition maps, and these high definition maps are built on top of the raw lidar data. So this makes it necessary for certain application to have the data. For example, if you look at our campus demos, most of those demos made use of lidar. But if you look at the outside campus demo, some of those demos make use of lidar, some of them totally don't make use of the lidar. And off-road downside demo, these are like, in off-road currently we are not worried about the sensor part. The harder part in autonomous driving is to develop the intelligence. So once the intelligence is developed, the question is how sophisticated that intelligence is to
Hmm.
be able to make sense of the visual sensory data. And we have been demonstrated through perception algorithms that lidar is making use of lidar, and without if you look at the January 31st 2022 demo, that was done without the use of lidar. Just using one single forward facing camera, the vehicle was able to negotiate the traffic and was able to keep itself on the lane as well. If you look at all the demos before funding from 2017, 18 and 19, they were all done without the use of lidar. Back then we did not even have money to buy the lidar, so all
Hmm.
the demos from highway to colony, everything was done. Currently our goal is to, whereas the world has invested into perception and mapping, we are investing in decision making and planning, right? So that is where the crux of autonomous driving is, and that's where when you're showing the capability, what kind of sensor we are using doesn't really matter much. It only matters what allows you to sort of create the whatever the acceptable level of tolerances in the representation of the environment. Any sensor that allows that, depending on the algorithm we have developed, it's okay for us to do the demos for now.
Okay, got it. So there are advanced global companies such as Baidu and Waymo that are already
Yeah,
doing level 4 autonomous driving for ride hailing.
sure.
In the US.
Yeah,
Autopilot, I think, is still at level 2, categorized at level 2. So I want to understand what are your opinion on the technology these different companies have. Uh, what is the approach these companies are taking to solve
sure,
autonomous driving, and
sure.
what are the main challenges you see there, and how is your approach different from each of them, in simple terms?
Sure. Simple terms, sure. So Waymo and Baidu had taken classical approach to autonomous driving, where the classical approach, what does it mean? So your autonomous vehicle have visual sensors to, so any algorithm that process the visual sensory data and build the 3D representation of the world around the vehicle, we call them perception algorithms. Similarly, there are sort of localization and mapping algorithms. So these algorithms are responsible for building a map for autonomous vehicle, the high definition map, and globally accurately localizing a vehicle with respect to those maps. Then the third front is your planning and decision making. So what the world had done, not just Waymo and Baidu, but most of prominent startups, some of them who have shut down as well, they have invested only in perception and mapping localization. So now the thing is there's a lot of intelligence. I mean, even for example, earlier you had classical computer vision algorithms to solve the perception problem. Now you have deep learning algorithms to solve those problems. But the level of sophistication that is required in the decision making and planning stack, that is missing from these major global players. And similarly you can look at, so these they can make claim of I think Cruise made claim of level 5, uh, and when I look at the demo of Kyle walked, he shared the demo in San Francisco where the vehicle negotiated 200 vehicles, on the streets of San Francisco. It was, the video was played at 10x. You can look, I'll forward that video as well after this interview. So now, if anyone looks at that, they will think, oh my God, Tom Sawyer is solved. But if you closely analyze the demo from a technical standpoint, it was nothing more than a stop, check, proceed demo. If something happens, the vehicle stops and do moves. You can replicate, anyone can do this. I mean, anyone with good enough resources can do this. But the when we say level 5, what I think we should be discussing is what is the level of unforeseeability and unpredictability and the chaos that the vehicle can deal with. If you want to explain, if I want to give sort of one paragraph explanation, I will not go into the technology framework that we are developing, or how we are, what technology, how we are different, they are different. There's a lot to talk about. But if you look at the questions that are raised in transferring, if someone suddenly jumps on the road, what will happen? The reason for that is that the representation of an autonomous vehicle, just like we visualize the environment through our eyes, vehicles visualize that and maybe build a local occupancy grid, where the information is projected as to what is what in the environment. This is deterministic. There's no the vehicles, the planning algorithms cannot deal with the probabilistic representation, right? And that is where all of these questions stem from, because you have determinism over there, so you cannot deal with probability. If you induced probability over there, your planning algorithms won't be able to deal with that, because the past 20 years of motion planning has not been able to deal with that. It gets converted into class of problem, which technically speaking is known as NP hard. It's very like chance constraint formulation if you induce probability. In a nutshell, what we have done is create an intelligence system that talks in terms of probability to the environment and to the other algorithm, and to the planning algorithm it talks in terms of determinism. So the planning algorithms don't have to deal with that complexity, and the system is able to take care of the unforeseeability and the unpredictability part of the environment. And we just a classical way of doing that. I mean, we are saying classical because the moment you induce deep learning, then we call it non-classical. So in a classical sense, the demos that we had done even in the past, they were able to deal with all of the complex scenarios where we had done the demo. If you look at for February 2023 demo that we did in campus, you would notice our vehicle never completely comes to a halt in none of our demos. There was only one exception in the entire demos that were done so far in the history of Swaayatt. When we were doing bi-directional demo, that was the only time where a vehicle came to complete halt. Whereas all of the other companies, they stop, analyze, and then proceed. We have the level of intelligence sophistication, you can say, that the vehicle is able to analyze as to what other pedestrian or what other vehicle is trying to do, and to make decisions just like human drivers do. And so the technical frontiers that allow you to do this, I'd already mentioned. I mean, some of the prominent companies who are making use of reinforcement learning, DeepMind, but they do not work in autonomous driving. Then you have OpenAI. One of the instances of is ChatGPT, and then there's also Wave AI in the UK, who is actually taking reinforcing approach to autonomous driving. And you can look at their demos as well. I think we consider them as one of the prominent competitors in autonomous driving. Waymo, Baidu, Tesla, like if you look at the work of Tesla, like currently they are doing what is known as auto-regressive sort of RL. What it means is that you're going to collect data, humongous amount of data from all the people who are using your vehicle, collect the data and try to train the algorithm to that data. You try to generate a reinforcement signal to train your machine learning algorithm. So this is the approach taken by Tesla, which I think is going to be very prominent because it requires a lot of resource, and that's the reason why not everyone can do this.
Okay, understood.
Yeah.
So, with respect to your company, what is it that you're working on right now? One, in terms of technology, and second,
Okay.
in
Yeah.
terms of business. I mean,
Sure.
you
Sure.
are obviously a funded company. I think you're
Sure.
looking to raise more money to develop
Sure.
your algorithms further.
Sure.
But in terms of business, how do you plan to take it to the market? Who are you
Sure.
speaking to? And
Sure.
some.
So regarding technology, before 2021, I could give a very clear answer as to what we are doing. After
Okay.
2021, it's very complex for even me to explain what we are doing. So we have many different frontiers now. Like earlier, we were working both classical and non-classical frontier, and currently it has grown into multiple branches as well, right? And in a nutshell, like I mean, if one of the representative demos I think would be like number 15 2017. Then we have bi-directional demo, then toll gate, and very recently on the eve of new year we did a Bhopal city demo. So these are some of the representative demos of some of the technologies that we have been building. So some of the areas that you're working, like inverse reinforcement learning, as I already mentioned, where the vehicle is there's certain problems that you cannot solve no matter how much data, resources, whatever you throw at it. So because the state space is like humongous, right? So like some of the problems like overtaking, learning to overtake on typical two-lane roads in India and abort overtaking just like human drivers do. This is one of the problems that we're actively working on. The bi-directional negotiation demo, if you look at the article also that I wrote about it on Medium. I mean, this was a classical reinforcement approach that we took to actually solve the problem. We are currently taking that framework, training it, extend further through deep reinforcement learning, and this would allow bi-directional negotiation close to 80 kilometers per hour on the same road, where we did roughly 40-45 kilometers per hour demo, where the vehicle would be having the intelligence to know how much to shift off road, when to shift, and at what speed to shift, without even making use of lidar, just using forward facing cameras. Similarly, there are like regular like city stochastic traffic negotiation. This is the problem that we are solving. I think it will take, this brings us to the business and the funding as well, right? Because some of the problems that we are solving, they require humongous amount of resources. Just I mean to give you an idea, I mean, just don't take our September and the recent off-road demo, just go back 2023 April, that the demo that we did. We are $3 million funding started. So far, we have spent only $500,000 in total on the funding that we have received. And this is where we have brought autonomous driving to all the frontiers. There are companies who have raised just $100 million just to solve that part of the problem. So that is the kind of, and if you compare with Waymo and Tesla, I think they have like 5,000 times more funding that what we have. So definitely doing all of the, we are doing that, and we will be going to bring like many different demos this year. But having said that, some of the demos require signal much more resources. So currently our objective is to raise another like around maybe like either we'll go for remainder of the seed round, where we may end up raising 12 to 15 million dollars, or we may raise directly pre-series of 30 to 40 million dollar. And I think to a certain degree, like we have commitment from some of the I cannot name names, but some of the investors have shown interest, even in India, to invest at around $250 million valuation of around 12 to $15 million, something like that. Yeah, I mean, so once we raise funding, the goal would be to take the technology to the next level, make it global. So we would want to, we ideal would want to take technology to the US as well, because that is one of the biggest market for autonomous driving. And furthermore, like we have understood, I mean, no one has been able to launch a successful ADAS system on Indian roads, right? We are a full-fledged autonomous driving company, and ADAS is a byproduct of the technology that we are building. So immediate goal with the next round of funding would be to launch our ADAS system. This would be the ADAS system for Indian market. It would be able to keep the vehicle on road. I mean, most of Indians, in most of ADAS systems in India, they can only keep the steering wheel check only when there's a proper lane marker, or well paved road. We have already the capability to do that even without lane markers. So this ADAS system would be the ADAS system with many different features into it. So this is one of the products that we are planning to launch with the next round of funding, hopefully by the end of this year.
All right. And when you say you launch the ADAS as a product, so generally, how much time does it take from you to make the product available and from till an OEM is able to test and integrate it in their vehicle? Generally,
Sure.
how the period?
So I wouldn't I wouldn't be able to discuss much about the homologation part, because I mean that is a very it's a bit time consuming and a complex process as well. But from the technology readiness standpoint, I mean, currently we are not just dependent on OEM integration. If you look at the vehicles that we have been using Mahindra Bolero, very recently Mahindra Thar, and we have Fortuner as well. So we have three vehicles, and in all three vehicles, we have done retrofitting, right? So we may not just develop the algorithms and license it to him. That is definitely one of the business models. I mean, because of the nature of the work that we are doing, and the number of frontiers for which we are developing the technology and start solve the problem, it opens up a wide variety of opportunity for us. For example, our technology has defense application, and we are talking in the defense domain as well to someone to actually take a technology for defense apps. So that is one of the one of the business frontiers. ADAS, we may end up with that level of funding. We may end up developing our own SoC, system on chip, where we would have our algorithm which can be retrofitted to the aftermarket vehicles as well. So it is not just the OEM integration, but also the retrofittable market product that we are actively sort of working on.
Okay. And what is the current team size at the moment?
Currently, we have 15 engineers, 1 5.
Okay.
Yeah, yeah,
All right. And what kind of a skill set and talent do you require, to be able to
sure.
develop algorithms?
Sure. So far, since we have been mostly an R&D company where we are investing into developing new algorithm, mostly we look for deep mathematical expertise with the ability to program the sort of any kind of mathematics in C++ or Python. So earlier, like programming and data structure and all of this did not matter much to us. But yeah, currently, since for some of the domains we have developed the technology, we have developed the algorithms to an extent that we can call it a technology. So to extend the technology further, like we are hiring now developers as well who have like immense like programming expertise. But earlier, like since we have been an R&D company, we typically look for very deep mathematical expertise, typically like someone who would have like gained except one of the areas of theoretical CS or mathematics or both.
And how easy or difficult is it to find such talent?
It's very hard to find such kind of talent in India. So yeah, so because like most of the people that you're looking for who would have this kind of, they would have already gone outside India, to pursue masters or PhD. So yeah, I mean, so we also like have like it's why we have internal education system as well. Earlier, like the system was there and it got converted into a different startup. So I too own two startups now. So the
Okay.
Deep Agin is an online education system which was part of the Swaayatt. So we actually invest a lot in the people who join us in
Mm.
educating them. Everyone is supposed to read something every week and sort of develop, invent, what you want to call it, some new algorithmic frameworks and new ideas to actually solve the problem. So but in general, yeah, this is going to be a challenge. I mean, if you currently, I mean, if you want to scale this kind of company in India, you'd have to invest significantly in the education system as well to actually create the entire ecosystem. And I think with the two startups, we are actually, to a certain degree, I believe we are solving that part of the problem as well.
Okay, that's again very interesting. So, I think okay. Thank you, Sanjeev, so much for taking the time and also explaining very patiently about your work and overall your vision of the autonomous driving in a global context. Thank you so much, and I wish you the very best. And I hope to see a lot more demos and a lot more exciting announcements coming from Swaayatt Robots.
Thank you so much, Prakshi, for having me here.
Thank you.